Welcome student and viewers. Today class we are just entering into LP and that too in graphical solution of an LP sum. This is what we are going to see in just today's class. We are taking an example of a firm. This firm has these three inputs at their disposal: labor 400 hours, capital 300 units and land 1000 units. Now there are three just technologies of making X and Y. So first composition is 4 units of labor is just needed for X and 1 unit is of labor is just needed for Y. 1 unit of capital is needed for X and Y, and 2 units of land is needed for X and 5 units of land is needed for Y. These three are the available resources at the disposal of the firm, and per unit profit on X the firm is earning is ₹2 and per unit profit on Y is ₹1. Now this information has to be expressed in the form of a standard linear programming sum. Since here we have to maximize profit, so this relates to the maximization program. Maximize Z 2x plus 1y subject to 4x plus 1y less than or equal to 400, 1x plus 1y less than or equal to 300, and 2x plus 5y less than or equal to 1000, x and y positive. As before, this is objective function or goal of the firm. These three equations in the form of inequalities are technical constraints or functional constraints. And this is non-negativity restriction. Now before I go to plot all these three lines, I must tell you about this straight line. All these three lines, when these three lines will be plotted, we shall get a downward falling curve. Now regarding this curve, we must know one thing, that if any equation is ax plus by equals c, and if it is plotted, then this will be a downward falling curve, one thing, and slope of this curve would be coefficient of x divided by coefficient of y. Now this could be verified. This is a right angle triangle, so its slope would be p by b, so b by c, a by c, so b by c into c by a. Just a minute. You let it here. Slope of a is minus a by b. Minus, since it is downward falling, and the absolute value of the slope happens to be a by b. This is what we get. Now these three lines will be plotted and we shall need the slope of each line. So first line is for the first is this objective function. Objective function, its slope would be the coefficient of x by coefficient of y, that is 2 by 1, 2. Second constant 4x plus y, its slope would be 4 by 1. Third is x plus y 300, its slope would be 1 by 1, that is 1. And the final last equation is 2x plus 5y equaling 1000, and its slope would be 2 by 5, that is minus 4. These four slopes have to be kept in mind, and that will be used when we are going to plot all these three lines just. Now we plot all these three constraints. First is 4x plus y is 400. So to plot it, very simple, on x-axis the intercept would be 400 by 4, that is 100. on y-axis would be 400. So 100 and 400. This is the first equation. Second, x is 300, y is 300. So 300, 300. And thirdly, on x-axis intercept would be 1000 by 2, that is 500, and y-axis 1000 by 5, that is 200. So this way we have plotted all these three lines, and this is how this appears. Now next is we have to find the feasible region. The feasible region is that region which fulfills all the constraints as well as the non-negativity restriction. This was non-negativity restriction. We are plotting on this positive quadrant, x positive, y positive. So this is fulfilled, and now we have to find this region within this diagram where all these three constraints are fulfilled, and absolutely this region fulfills all the three constraints. This is first constraint, this is second constraint, and this is third constraint. Below, we are below, so, and all the inequalities are in the below form. So this ABC, this entire area is known as the feasible region. Feasible region, those region where most expectedly the optimal solution has to lie, and their optimal solution will lie. Now in this feasible region, firm will never produce within this ABC boundary. Rather, firm would produce only on ABC boundary itself, not within the boundary. Now, which intersection, either A or B or C, which point would be an optimal solution? For that we have feasible region is A, B and C, feasible points rather, and we have a rule of slope. Now we have just plotted on the plotted all the constraints, and we are supposed to maximize the profit. Nowhere profit appears in this diagram. This is the profit function. Now what we do, this profit function is plotted on a graph, not in this form, rather it is written as y is z minus 2x. We take different value of profits, and for different value of profits we shall get different downward falling lines like this. For different amount of profit we shall get this type of downward falling curve. So we start plotting different profit curves. Now the optimal solution is defined by the tangency of this objective, this profit curve and the feasible points. Now what we see, that this profit curve is just passing through the point B intersecting two constraints. Now this will be optimal solution. Mind it, this is a very important point. This point B would be the optimal solution if slope of objective function is greater than the slope of one constraint, but it must be smaller than the another constraint. This rule has to be followed for finding optimal solution. In graphical, any intersection in the feasible region would give us an optimal solution if on this point of intersection the slope of objective function or the slope of profit function lies between the slope of two intersecting lines. Now see what is happening at point B. At B, slope of objective function already we have found out is 2. Now we have two lines, 400 and 100. This one, so its slope is 4. So 2 is smaller than 4. And another is 200 and 500. Its slope is 0.4. So absolutely 2 is greater than 0.4. This slope criteria authenticates that point B would be an optimal solution, because this point is tangent to the highest isoprofit curves. When we take the different values of Z and when this is plotted, then we get a family of isoprofit curves. Isoprofit curves, and we start just plotting isoprofit curve from the below. Say this, say 100 profit, this 200 profit, this 300 profit, let this is 400 profit. So for the higher profits, we get another isoprofit line, and we go on sketching and just plotting the isoprofit curve, and that point of intersection would be an optimal solution at which the slope of this isoprofit curve lies between the slope of two intersecting lines, and it is very much verified right at point B. So point B is the optimal solution, and the two coordinates of point B will give us the value of x and y that the firm will produce. So at point B, x and y, x is 55.5, we take it as a 56, and y is 178. And when these two values are put in the objective function, that is the profit function, so maximum profit is x plus 2x plus y. So 2 into 56 plus 178, and this is 290. So this is how firm maximizes profit, and this is the crude mechanism of linear programming where profit is maximized. Just conversely, if we were concerned with the minimization of cost, then these lines will be iso cost line. So there we shall plot iso cost line. In the case of maximization of profit, we plot iso profit line, and for different value of Z bar, just this has become constant. So we take different value, 10, 20, 100, 200. So we take different values of Z. Corresponding to that value, we get isoprofit line, and we go on plotting the isoprofit line till it passes through one of the intersections, and that intersection will be an optimal solution if at that intersection slope of objective function lies between the slope of two intersecting lines, and this has been well verified right here. So this is what linear programming entails for maximization or minimization. Right, today we were concerned with the maximization of profit. In the same manner, we shall be minimizing the cost, and this is how this graphical solution has. In next class, we shall solve some complex problem of graphical type that I shall do in the next class. This is all for today. Well, students, now today I have explained this sum on this blackboard. If you want, then you do give me your own views on the comments. I shall do it on a graph paper. Then I will show you in the next class. We shall take some typical sums of graphical solution in the next class, and there I will solve. We shall have a mesh constraint and the minimization of cost. So another 1 or 2 class I am just going to spare for this graphical solution. Then I shall enter into simplex method. So you just make comment, your own views, own likings, dislikings. These all things you do give me in the comments, and just I will follow it. And whatever questions you just come across in your own study, you must ask me. I will be answering in the class very happily. And for today, thanks.